Database design best practices. In this lecture, I will share some techniques to make good use of visual paradigm to improve the productivity and stability of your database design. Let's take a look about the typical approach of the database design development in our software development team. Typically, we will develop the initial database by the development team altogether. This will have quite a small numbers of tables and columns just for initialize the development. However, from time to time when developers need tables or columns to store their information, they will add the tables and columns by themselves. Ideally, everybody will update the data definition language file, the DDL, for initializing the database environment when we roll out to the production. But the problem comes when someone forgot to update the DDL accordingly. Then we run into the productions will have a lot of problem because some columns or table are missing. Nowadays, we have some visual development environment bundled with the database vendor like the MS SQL, Oracle Designer. But it doesn't solve the second issue, is the duplicated columns. Since we don't have any control, so everybody can add the columns, add the tables they want, you will come up with a column called email to store the email address, and also another email address to store the email address. So that will lead to the data inconsistency. Furthermore, the database specifications will become outdated immediately because nobody will spend time on both. They will just rushing on create a column and do the programming. Visual Paradigm suggests an approach that you can maintain the good design together with an efficient. We suggest you work two team members as the database designer. Here, the two team members does not need to be a full-time designer. They just responsible for update the design if they request. And let's take a look. If someone just asks, I need a table to store a deletion histories, then they will say, okay, let me just add a table. And if someone want to have a column to store the email address, they will add the email address columns, and they will also update to write the descriptions of the column. We said we need two people. Is if someone is on leave, you still have the other one can pick up the work. And the database design after you set up the initial one will not be so heavy. So we just need to have some part-time workload, the role to maintain it. And the idea is after they update the database, they just commit to the repository. And the developer can get the design immediately and generate the update the database, the development database they want to continue the development work. Let's take a case studies on it. Assume we have a team of 5 people: John, Peter, Russell, Mary, and David. Assume John is worked as a database designer. To keep it simple, we just pick one. And Peter just want an extra column to store the email address. Let's see how it works in action. First of all, Peter will create the task to join in the taskifier. The taskifier is the task management system in Visual Paradigm. You can make use of it. It's free of charge in the repository. He just create a column and state why he need the column. And John will receive the notification and open the task. And then he update the database to see any duplicated column. If no email before, he just add the email column. And then he write the descriptions, who request and what's the purpose. John will commit the change to the server and mark the request URL as a comment when he commits to the Visual Paradigm server. And then John mark the task complete. Now back to Peter. He find the task is completed. Then he can update the change from server and generate the update database script to upgrade to the updated development environment. Regarding how to do the update, you can revisit the previous lectures. We talk about how to update the database instead of reinitialize all the tables and columns. The benefit of this approach is we have a common database environment for the entire team. Everybody, when they update the change from server update, generate the update script to the development environment, all the team member has the same database environment. They will see the email address immediately after John just committed. And there's no duplicated column anymore. And since John will do the safeguard to avoid duplications. And the great benefits is the production database is ensured to run without any issue. Finally, the documents are always up to date because John is keep updating the table and descriptions. The second technique I would like to share is to design for very large database. If you're developing a very large system, most likely you will have a very large and complicated database design. Without help of the design method, to maintain and design the large database is very, very complicated. In Visual Paradigm, we suggest to use the context-based database design, and you can draw multiple database design diagram instead of one giant entity relationship diagram. The team member can focus on a smaller set of the table instead of finding which table relating to each others in a very, very big database design. With the context-based design, you can reuse the entity in different design. In this example, we reuse the photo table in photo upload ELD and photo commenting ELD. When you update one of the photo table in either the diagram, it will reflect the change in others. You don't need to spend your time to keep it up to date and consistent. To reuse the entity is very simple. You just need to press the control space when you create the entity. Then you will see a list of the list of entities you already created in your project, and then you just pick them. Then you will see the full detail showing in the entity relationship diagram. Let's summarize what we talked about in this lecture. We talk about the typical approach of database design and the typical problem. We have suggested approach for database design and development. We also propose to have a multiple entity relationship diagram to do the database design for very, very large systems.